Okay, so we are going to start another example. In this example, we'll consider population by state from 2010 census. So it's in million. So like for example, histogram is this is the histogram of state population. California is here about 37 between 37 and 38 millions. Texas is here, more than 25 million. New York, Florida, and other states. So histogram is here, and we are calculating the average. We calculate the average, and then you can calculate the mean is here. Of course, the mean is calculated from the underlying data, not from the histogram. So the mean is near 6 million, right? 6 million is here. And then we have a strange graph because I told you the mean is a measure of central location. It is a more typical or representative or like the center where the data are located around. But look at this. On the right side of the larger side of the mean, there are only 17 states. But below the mean are 34 states. That is, there are twice more states smaller than the mean, right? Than above the mean. Well, then it is not a center. It is kind of it is biased toward the larger side, right? There is something not correct. Now, I mean, there is some kind of it may be misleading. What I meant is I didn't mean it is not correct, but possibly there may be potentially it could be a problem in interpretation of the mean as a center. It's not actually it's not a center. So it is an unbalanced center. Somehow it is not balanced. So we are going to define a new measure that will make that is a center that balances on each side. That balances both sides. And so that simply it's the point where the sample is cut in half and half. So that is the median. Median is denoted as median of x or simply MED of a random variable x. So it's a random variable x. And in our example, there are 50, actually including DC, there are 51 states. And then choose 26 largest or smallest states. 26th is Kentucky. If you choose Kentucky, then 25 states are smaller and 25 states are larger. That is, Kentucky will balance the sample on both sides. And Kentucky's population is 4.34, so we call this the median. This is literally the center that balances the number of observations on both sides, right? It's literally the center. And usually the mean and the median are different, as you just saw. Like mean is 6, greater than 6, but median is only 4.3. So they are different measures, but both try to capture some kind of center. But the definition of center can be is different. The definition is different, so their interpretation and their usage is different, right? And it is easy to calculate the median if you have the data. So for example, if you have raw data, what you do is just find the middle value. Like if you have an odd number of observations, just rearrange the observations in the ascending, or actually you may arrange them in the descending order. Does not matter. Just choose the center. There are 5 observations, then choose number 3. That the third smallest observation is the median. By the way, the median is 3.8, but the mean is 9.9, right? So if you only have five observations, it's like 3. Number 3 is the middle. And now suppose that there are even number of observations. Like suppose we are interested in the median of New England states. There are 6 states, and when there are 6, you have to cut them into 3 and 3. But then there is nothing in the middle. So in this case, so I have already arranged the observations in the increasing order. Then you have to choose something in between New Hampshire and Maine. And the median will be the average of those 2 middle values. So there are 2 middle values when there are even number of observations. Then choose 2 middle values and take the average of them. So the median is 1.325, and again it is different from the mean, quite different from the mean. Like in this case, the mean is nearly like 3 times larger, and in this case mean is nearly twice larger. So almost in any case, the mean is different from the median. So keep that in mind. They are different. And I just explained how to calculate the median when you have the raw data. It is straightforward. However, when you have probability, it is not that simple. So when you have probability, you have to divide the probability into half and half this way. The median, ideally, the median should satisfy smaller side has 50%, greater side has 50%. But in some cases, there may be no value that exactly make the probability equal to 50%, right? So in that case, you relax the probability this way. Greater than, both sides should have greater than 50%. How can this be possible? Because one point, both inequalities include equality, right? Smaller or equal, greater or equal. So the equal part is double counted. So it is possible to have greater than 50% on both sides. You will see with an example how this is possible. So now think about another numerical example. I will consider the number of pets per household. Say 28% of households have 0, and 21% has 1, 19% has 2, 70% 3, 4%, 15% has 4 pets. Based on this probability distribution, let's find the median. Given the probability, again, you have to choose, you have to cut the sample into 50% and 50%. Let's see how we can do it. What I'm going to do is, so when you have raw data, you rearrange the observations in the ascending order from the smallest to the largest. But when you have probability, what we are going to do is we are going to calculate the probability from the smallest. So, and define the cumulative distribution function. Idea is the same. From the smallest, let's calculate sum up the probability. So, for example, at each point, like say at 3, the cumulative distribution function gives you the probability from the smallest up to 3. So from the smallest up to a certain value. Look at this. So at 0, cumulative probability is 28%. So the cumulative probability is 28% from the smallest up to 0. So just itself. And when you move to 1, the cumulative probability is summation of these two probabilities, right? So so from the smallest up to 1, so the summation is 49%. Like that, the cumulative probability at 2 is 68%, and at 3, 85%, at 4, 100%. So at the largest value, cumulative probability is 100%, right? And here, there is no 50%. Of course, 49% is very close to 50%, but not exactly 50%. Think about, we want it equal to 50%, but there is nothing like this. There is no probability exactly 50% in our cumulative probabilities. In that case, we will make the probability greater than 50%. So we have to find the first value with cumulative probability greater than or equal to 50. That is this one. So these values have cumulative probability greater than 50%, but 2 is the smallest value, so we take this as the median. 2 is the median. Now, you can see this. Probability smaller than, probability smaller than or equal to 2 is this guy, 68%, which is greater than 50%. And if you calculate probability greater than or equal to 2, then if you calculate that probability from here, add these 3 probabilities, then you will get 51%, which is also greater than 50%. So as I said, we can make both sides greater than 50%, as in this example, because this point, median point, is double counted on both sides. So it's not choosing the nearest value. You have to go over the bar. You have to go beyond 50% first, and then choose the first value you encounter. Okay? So this is an exercise. So this data is about household size, how much people in a household. So try to calculate the median and resume when you are done. Okay, you have to calculate the cumulative distribution function or the cumulative probability. Cumulative probability is straightforward. Just add up, keep adding up from the smallest. From the smallest outcome, try sequentially add up the probability. And what we are looking for is greater than 50%, which is already achieved at the second step. Number 2 is over 50%, so that is the median, according to our definition. So once you go above 50%, you don't need to calculate cumulative probability here. To calculate the median, to obtain the median, what you need is to calculate the cumulative probability until you see greater than 50%. That's how you calculate the median. So in this slide, I described how to calculate the median. And remember, when we learned how to calculate the mean, there were 2 different methods. when the information is in raw data or in probability distribution table. You have to use two different methods. Similarly, for the median, you have to use two different ways to calculate the median, right? So when you have raw data, it's pretty simple. Just rearrange and choose the middle one, right? Just minor problem when you have even number of observations, not a big deal, right? I don't worry too much about this. But when you have probability distribution table, then it gets more complicated. In that case, you need to calculate the cumulative probabilities from the smallest up to a certain point, and then choose the smallest value greater than 50%. That is how you calculate the median when you have probability distribution table. So I want you to see the parallel structure between the mean and the median. And in the next video, I am going to compare the mean and the median when you use the mean and when you use the median. Okay, see you in the next one. Bye.